Hi. So, what we're going to do today is talk about a hypothesis problem, a hypothesis issue, where we have 20 patients. I just realized that. A hospital has a historical daily average charge of $12.40. They want to know, this is our hypothesis here, they want to know if the average daily charge has increased over time. Okay? They take a random sample. Let's talk about the random sample. Here's our random sample. They take a random sample of 20 patients and learn that their average daily cost is $14.91 with a standard deviation of 342. This is our sample. Okay, so that's good. What do we know? Well, we're going to test a hypothesis here, but before we do that, we should probably do our little mathematical cheat sheet. We know that the historic average daily charge, historic, this is the expectation, right? This is what we expect to find. So that's going to be our mu, is equal to 1240. We have a sample of 20 patients, n is equal to 20. And their average daily cost is that's X bar, $14.91, with a standard deviation of 342. Now, is that going to be the standard deviation for the population or for the sample? The way this is written with the word with, right? The word with here tells me that this is derived, the standard deviation is derived from the sample. So that's going to be an S, 342. Alpha is 0.10, 0.10. And I'll tell you right now, you can already see that we're going in a particular direction, that the degrees of freedom is going to be n minus 1, which is going to be 19. So we'll get to the rest of this in a minute, but here is our 10-step process for conducting a hypothesis in statistics. We'll start by writing it out in English and then going from there. Those of you who have been with me already know about our 10-step process. So let's go ahead and start with step number 1. Write the hypothesis in English. So we never start with the null. We always start with the alternative. This can be an A if you want it to be. It doesn't matter to me. And what is our hypothesis? Well, this line here in green says they want to know if the average daily charge has increased over time. So I'm going to turn this into my alternative hypothesis, into my H sub 1 or my H sub A, and I'm going to say the average, a statement, not a question, right? The average daily charge has increased, right? And so the null hypothesis is the exact opposite. The average daily charge has not increased. All right, good. 2, select a statistic. Well, we're going to use mu. Okay, that was easy. 3, is this one-sided or two-sided? Well, increased, if I were to do this and I were to say, here's what it is, and I want to know if it's increased. Do I care if it's decreased? No, I don't. I could care less. So this is going to be a one-sided test. In fact, I'm going to erase that one. It's going to be one-sided. All right, number 4, we're going to write our hypothesis in regular math. I'll keep that right there at the top of the screen. H sub 0, H sub 1, or H sub A in this case, the way we've written it. The average daily balance, that's mu, daily charge, has increased over what? Well, over the average, right? So what was our average? Our average was 1240. And we want to know, is it bigger than it has been? Well, what was it before? Before it was 1240. We want to know if our current mu is bigger than our old. Yeah, okay, that makes sense. And then this is the exact opposite. Less than or equal to. Don't forget the equal to 1240. The equal to portion always goes in the null hypothesis. Step 5, alpha. Alpha is given. It is equal to 0.10. Step 6, Test statistic. All right. So test stat. In this case, you're asking what is the stat associated with the distribution. This could be a z, or it could be a t, or it could be a chi-squared, or it could be a lambda, you know, or whatever. Most of the time, we're going to deal with z's and t's. And so this question is, do we know sigma? Do we know sigma? Is sigma known? Sigma known? And you know, I have a cheat sheet right here where we were talking about this a minute ago, and this is S, right? Which tells me that the standard deviation comes from the sample, not the population. The sigma known? No, sigma is not known. Is n then, the next question we ask, is n greater than 30? Well, again, n is right here, right? N is not greater than 30. It is not greater than 30. So we're not going to do a z. We're going to do our t for a test statistic. Number 7, critical value. Critical value at alpha is equal to 0.10. This is a great time to write out or to draw out a normal distribution. When in doubt, draw it out. And I find that students begin to have doubts in the process when they hit the critical value. Remember that the critical value is not the calculation of the statistic. Not the calculation. You're not going to calculate anything right now. Okay? In fact, it's easier if I just erase it. So let's draw it out. Do a normal distribution. Something like that. That is really terrible. Let me do another one. We'll do a normal distribution. Look something like that. And we know, because alpha is 10, that we are looking for some critical value where 10% of the distribution under the curve, 0.10, or 10%, is on the right-hand side. Why on the right? Because we're looking for an increase. Remember, this is a one-tail test. It is over here. My critical value is wherever this guy exists on the t distribution, right? That's my critical value. How do I get this critical value? Well, I don't get this by doing the calculation. We already talked about that. Don't do your calculation yet. Here, we have to go to the table. And lucky for you, I have a table right here. Ta-da! Let's make that a little bit bigger. Whoa. Let's make that a little bit bigger and readable. That's about right. Let me bring it down, let me bring it down, let me bring it down. Okay. It looks a little fuzzy, actually. Do I have a different table somewhere that I don't know about? Why is that fuzzy? Okay, let me bring up a different table. That's not it. Let me get you a different table. How about this one? There you go, that's better. So here is our t-stat table. That's much better, much better. I'll put it over here on the right-hand side so we can play with it a little bit. And what do we know? We know that we are looking for, this is alpha at 2.0, this is alpha at 1.0, so we're going to look for this one. This is alpha at 0.05, 0.025, and so on. This is the one we want. This is t at alpha, or in our case, we want t at 0.100. All right, so that's good. And then this, remember that our vertical column is in degrees of freedom, right? Degrees of freedom is equal to n minus 1. So 20 minus 1 is equal to 19. We kind of have that in our cheat sheet already, but I'm going to go down here until I get to 19. And I'm going to walk across this entire deal. And I'm going to walk down this one until I get to 1328. So 1.328 is equal to my critical value. It's beautiful. Beautiful. So what this means is there is a t, no, we'll stick with t. This x-axis here is in t's, so to speak, and my critical value is 1.328, right? 1.328. Let's hold on to that for a minute while we go on to step 8. Step 8 is make the actual computation, right? So let's go back to step 8. 8. Now, in a t-distribution, it's very similar to a z-distribution in terms of the calculation. X bar minus mu over s divided by the square root of n, right? And at this point, it's plug and play. We can go back to our, where is our cheat sheet? Let me see if I can do this with a cutout. Nope. Yes. Take the whole thing. Control copy. Oh man, love this. Love this. Love it. Love it. And I'm going to paste it here. That's paste. Yes, it is. I'm going to paste it over here. So there's my cheat sheet stuff. So X bar is 1491 minus mu, which is 1240, divided by S, which is 342, over the square root of n, which is 20, right? So that is equal to, where's my calculator? 1491 minus 1240 equals 251 over 20 square root is 4.4721, and 342 divided by that, 4.4721 equals 76.4741. One more calculation, 251 divided by 76.4741 equals 3.2822. This is t evaluated at, this is our t statistic. There's no evaluation here. This is just our answer. This is our calculation. So number 9, also a great place to draw it out, is our decision. All right, I suggest you draw, man, that's terrible. I suggest you draw out the entire curve at this point for practice. It'll make it super clear. All right, we have 10% of the area over here. All right, this is 10% or 0.10, where our critical value is here. Right, this is our critical value. And what was our critical value? Critical value was 1.328. 1.328. And here's where I'm going to draw my line. This is my cutoff line. Everything to the right, if we end up on the right-hand side, we will reject the null. And if we end up on the left-hand side, we are going to fail to reject the null hypothesis, right? And what is our actual statistic? Well, our actual calculated statistic, this is ours, right? The other one is the critical value and whatever, but this is ours. This is our calculation. And it's 3.2822, and 3.3 is over here somewhere. 3.28 is over here somewhere, clearly on the right-hand side. Our statistic that we calculated is greater than in magnitude, right? And we care about greater than right now because we're on the right-hand side. It is greater than 1.328. Therefore, we will reject the null hypothesis. 10, conclusion. Not a bad idea to rewrite your hypothesis. You can go back to number 1 and cross them off, but let's go ahead and rewrite them because we can. H sub 0, H sub 1. H sub 1 is that the average daily balance has increased greater than 1240. And our null hypothesis is that the average daily balance has not increased greater than 1240. This is the critical difference. We are rejecting the null hypothesis, so that's out. Our conclusion then is that there has been an increase in the average daily balance for the hospital.